They can contribute backgrounds that essentially make you less sensitive to the actual signature you're looking for, whether that's a very rare event in a physics experiment, or whether that's a very small amount of sample that you successfully collected from the atmosphere after a suspected foreign nuclear test.
We need this heavy filtering that goes on for a clean room to keep that dust out of the environment. Very small amounts of uranium could cause a problem for the dark matter experiments. Something like a milligram of uranium, which may sound like a lot or may not sound like a lot, but a milligram of uranium showing up in, say, 10 tons or 100 tons of shielding would cause the experiment to fail. So that would be a huge risk for the experiment. So having a tiny amount of dust that would add up to a milligram of uranium, as an example, would be a horrible problem for a dark matter experiment. It would cause us to spend something like $20, $30 million to build an experiment, spend 5 to 10 years of our life trying to run the experiment just to find out that a little bit of dirt had gotten into the experiment and it was a failure. So that would be a huge risk for us. So everything we can do to mitigate that risk, assembling, machining, our detector apparatus in a clean room is a huge benefit and reduces the risk of these experiments enormously.